So good morning to all. I'm Dr. Namita Priyadarshini, Professor of EC Department. And today's class we shall discuss about the automation system. So the industrial automation system is a combination of hardware and software components. So it is designed to operate and monitor the industrial process as well as the machineries and equipment without any human interaction. So in the manufacturing and other industrial contents, the system plays an important role in order to increase the efficiency and improve the product quality, and also it assures safety. So the important terminologies are: first one is PLC, and SCADA, HMI, sensors and actuators. So first is the PLC. PLC is known as Programmable Logic Controller. So it's a specialized digital computer used to control various electromechanical processes in the industrial environment. So next is SCADA. SCADA represents the supervisory control and data acquisition system. So it's a system used to monitor and control industrial processes and the equipment which are in operation. So the third terminology is HMI. HMI stands for Human Machine Interface. So it's a graphical user interface that allows user to interact with the automation system. Next, sensors. Sensors are the devices that detect physical properties like temperature or light and provide data to control the system. Actuators, components that carry out actions based on control system commands such as motors or valves. Next, types of automation system. So they are named as fixed automation, programmable automation, flexible automation, as well as integrated automation. First is the fixed automation system. So the fixed automation system, it is from the name itself, you can say that it's a hard automation system. So here the hardware is designed for a particular task and that will be ideal. That means the product or the hardware that can be used for what the purpose it was designed. So it cannot be modified. It can perform the only one task that is for which the system is designed. Next is the programmable automation system. So the programmable automation system, it offers flexibility by allowing reprogramming of the task for the different product variations. So they are commonly used in industries where product changes occur frequently, like consumer electronics. Third type of automation system is the flexible automation system. So the flexible automation system is which combines the advantages of fixed automation system and programmable automation system. So this can handle varying tasks with the minimal setup changes. The flexible manufacturing system fall into this category. Next is the integrated automation system. The integrated automation system, which connects the multiple processes and components into a single unified system. So these systems are prevalent in smart factories and Industry 4 initiatives where data exchange and analysis are very crucial. So next, the basic components of an automation system. So the automation system, which consists of processors, controllers, sensors, actuators. So first, sensors. So it detect the physical changes in the environment, and that will be monitored, and that is transmitted through the processor. Actuator. So it execute the actions provided by the processor and based on the control signals. PLC, which controls the unit, the process data and commands. HMI, interfaces for the human interactions. Control algorithm, software for decision making, and communication protocols, which enables data transmission. So different types of communication protocols are used. That, for example, that may be Zigbee or Bluetooth, etc. So next, working principle. So the working principle of the automation system, which depends upon the types of application. So for instance, in a manufacturing assembly line, sensors detect the position of the components, and the automation system operates on the premise of using hardware and software components to control and monitor numerous processes or tasks with minimal human intervention. The fundamental purpose in industrial or other applications is to improve the efficiency, productivity, and safety. So next, the goals and requirements. System development. So to create a detailed system design that outlines the automation system's architecture, that's a goal. So determine the hardware and software components required and create a functional specifications outline how the system will work, including the control logic, user interface, and communication protocol. Next is the hardware selection and integration. So here the right hardware components for the automation systems are chosen. So it is, for example, you can consider what are the types of sensors, actuators, and HMI devices are used for networking. Next, software creation. So creates control software for programmable logic controllers, microcontrollers, and other control devices. Installation of sensors and actuators. Install sensors to get information from the physical world, and debugging and testing. So test the automation system thoroughly to discover and resolve any software or hardware faults. So this testing, which includes the simulations and if possible actual processes or equipments are tested in real time. So advantages: because of automation, the efficiency is get increased, the accuracy is get increased, safety is enhanced, cost is reduced because of there is no labor, scalability and data collection is reliable and can be trusted. Disadvantages: so it is high initial cost, job displacement because of automation, enormous number of people will lose their job, which depends on the electricity. So in case of power failures, it cannot work, and also security risk will be there, and also vulnerable to security attacks. Thank you.